Assalamualaikum and good morning. Okay, now look at the last lecture for the topic integration. Okay, at the end of the lesson, you should be able to determine the area under a curve and between two curves for polynomial up to third degree functions only. And then remark here, graph of cubic functions must be provided.
So this lecture is divided into 3 parts. So the first part is area between the curve and the x-axis. The second part is area between the curve and the y-axis. And for the third part is area between two curves. Right? So for the first part, area between the curve and the x-axis, the definitions. Area under a curve can be computed using definite integrations. So if f is continuous throughout a and b, then the area of the region between the curve, let's say y equals to fx, and the x-axis from x equals to a to x equals to b is given by a. So a here is denoted as area. So what we have to do is we have to take integration from a to b for a function with respect to dx. Right, so we have 3 cases here. So for the first case here, let's say we put number 1 here. Right, so we have a region here. So this is the region, and you notice that this region is above x-axis. So we have x-axis here and the region is above x-axis. So when you want to find the area, what we have to do is, so a area equals to integration from a to b, so a to b, function fx, this one is the function fx. Alright, so with respect to dx. That is for the first case. For the second case here, you notice that this is our region and our region is below x-axis. Right, so when we want to find the area of this region, so we have to take integration from a to b. So that's why we have a to b here for a function. So this curve is given by fx with respect to dx. You might notice here we have the modulus here. So we need to put the modulus, because when we integrate the region below the x-axis, we should have negative value, but area always takes the positive value. So that's why we need modulus here. And for the third case here, right, so we have 2 regions here. Let's say we have this one, let's say we have region A, that's when we have region B, right? So we want to find the area, we have to split the integrations. Why? Region A doesn't need modulus, region B it need modulus because it is under the x-axis. So the total area A here is given by A plus B. So for the area A, so we have to take the integration from A to B, so a to b for a function f with respect to dx, plus integration from b to c, b to c for a function fx with respect to dx. Don't forget the modulus here. Example 1, find the area of the region between the curve of fx equals to 8x minus 2x squared, x equals to 2, x equals to 3, and the x-axis. Right, so for example 1, we are given the region already. So what we have to do is we have to find the area straight away. So a equals to integration from 2 to 3, and our function is 8x minus to x square with respect to x. Right? So we integrate this one. So for 8x, we should have 4x square minus 2 over 3 x cubed, and limits of integration is from 2 to 3. Okay, so next step is we substitute the value. So we have 4 3 square minus 2 over 3 cube, right, minus 4 2 square minus 2 over 3 2 cube. We close the bracket and you press your calculator. Final answer should be 22 over 3 units square. That is example 1. And for example 2, we have find the area of the region between the curve of fx equals to x square minus 2x minus 3 and the x-axis. Again, we are given the graph and the region here. So what we have to do here is you have to find the area. But you notice here, the region here is under x-axis and you must include the modulus. So for AM, for the area, it is given by integration from -1 to 3. For a function, our function is x square minus 2x minus 3 with respect to dx. Alright, don't forget the modulus. Right, so we integrate this one. So you might have x cubed over 3 minus x square minus 3x, and limits of integration is from -1 to 3. Right, and don't forget the modulus. So next step is we substitute the value. So we might have 3 power of 3 divided by 3 minus 3 square minus 3x. Oh no, not 3x, sorry. 3 close minus, careful here. So we have -1 power of 3 over 3 minus 1 square minus 3 minus 1, and we close. Don't forget the modulus here. And you might have this one, you press calculator correctly, you should have minus 32 over 3 modulus. So therefore final answer should be 32 over 3 unit square. The second part will cover the area between the curve and the y-axis. So the definitions here, area under a curve can be computed using definite integrations. So if G is a continuous throughout CD, then the area of the region between the curve, let's say x equals to gy, and the y-axis from y equals to c to y equals to d is given by A equals to integration from c to d, a function in term of y with respect to dy. right? So we have two cases here for the area between the curve and the y-axis. For the first case here, right, so this is our region, and our region is to the right of y-axis, right? So what we have to do in order to find the area is, so a equals to integration from c to d, so c to d for a function in term of y with respect to y. And for the first case, we don't need modulus. But for the second case, we need modulus. Why we need modulus? Because our region here is to the left of y-axis. So that's why we need modulus. So to find the area, which is denoted by a, equals to, we have to take the integration from c to d, so c to d, a function in terms of y with respect to y, and don't forget the modulus. If you forget the modulus, then your answer should be negative, and area cannot be negative. Example 3, the graph shows the curve y equals to negative x cubed. Calculate the area of the shaded regions about the y-axis. Alright, so we are given a graph and regions. So we have two regions. Let's say I put this one as region A and I put this one as region B. The difference between regions A and region B is region A is on the left of y-axis and region B is on the right y-axis, which means A needs modulus, B doesn't need modulus, right? So our function here is y equals to negative x cubed, right? I'm going to rewrite this function x equals to y. So x equals to negative y, x cubed equals to negative y, and x equals to negative y power 1 over 3, or I can rewrite this one as negative y 1 power of 3, and I'm going to use this one. For area A, right, so A, the integration is from 1 to 2, and function is negative y 1 over 3 dy, right? So we integrate this one carefully and don't forget the modulus, right? We integrate this one carefully, we should have negative y 4 over 3 over 4 over 3, and limits of integration is 1, 2, and modulus. We simplify the above and we should have negative 3 over 4 y 4 over 3, limits of integration 1, 2, and modulus. So next step, we substitute the value. So we have negative 3 over 4, 2, 4 over 3, right, minus negative 3 over 4, 1, 4 over 3, modulus, and you press your calculator, you should have negative 1.1399 modulus. Therefore final answer is 1.1399 unit square. That one is for region A. Check region A, right? So for region B, Right, so region B, we have to integrate. So B equals to, we integrate from -1 to 0, and our function is -y 1/3 dy. Right, so this one we use the previous integrations. So we have -3/4 y 4/3, and limits of integration is -1 to 0. So next we sub the value. So we have -3/4, 0, 4/3, close the bracket, minus -3/4 minus 1, 4/3, right? So final answer is 3/4 units squared, right? So total area equals to A plus B. So A is 1.1399 plus 3/4. Therefore final answer is 1.8899 units squared. Done. Example 3. Find the area of the region between the curve x equals to y square, y equals to 1, y equals 3, right? So different here is we are not given a graph or a regions. So what we have to do first, we sketch the function here. So when we sketch this one, we should have something like this, right? So this one is x, this one is y. So xy square, we have something like this, right? So this one is x equals to y square, y equals to 1 somewhere here. So let's see this one, y equals to 1, and another one is y equals to 3, and y equals to 3 somewhere up here, and this one equals to y equals to 3. Where is the region? So the region here, somewhere here. Okay, so let's say we label this one as E. Okay, to find the area, so A equals to integration from 1 to 3, function is y square dy. Okay, we integrate this one, we have y/3, y power of 3/3, and limits integration is 313, and we sub the value, we should have 3/3 minus 1 power of 3/3. Therefore final answer is 26 over 26 3 units. Done. Example 4. The final part for the area is area between two curves. The definitions: if f and g are continuous with fx is greater than or equals to gx, throughout AB, then the area of the region between the curve y equals to fx and g y equals to fx and y equals to gx from x equals to a, from x equals to a to x equals to b, is the integral of f minus g from a to b. Alright, so this one a equals to integration from a to b, so fx minus gx with respect to dx. Okay, so from the diagram here, from the figure here, we see that the fx is higher than gx, so which means this formula is valid, or you have to use upper curve minus lower curve. This one is x axis, so if y axis you have to take the right curve minus left curve, and this one is with respect to dy, and this one is a equals to ab. Okay, there is area between two curves. So we have example 5 here. Find the area enclosed by the curve y equals to x minus 3 power of 2 and the line x plus y equals to 9. So we are given the region here. Right, so what we have to find here is, so a here, so we have to take the integrations from here to here, which is from 0 to 5. So what is our upper curve? So our upper curve is x plus y equals to 9, but this one you have to rewrite, so we might have y equals to 9 minus x, so we use this one. So we take y2 minus y1 dx, right? So what is our y2? So limits of integration is 0 to 5. So what is y2? y2 is the upper curve, which is 9 minus x, minus what is y1? y1 is lower curve, which is, this one is our lower curve, which is x minus 3 square dx, right? So this one you expand, simplify. Don't forget to expand and simplify. You should have negative x square plus 5x dx. This one you get after you expand and simplify. Alright, so next is, I'm going to integrate this one. So we have negative x cubed over 3 plus 5 over 2 x square, and limit integration 0, 5. Next step we substitute this one, substitute, so we have negative 5 power of 3 over 3 plus 5 2 5 square, right? So this one minus this one. So if you substitute 0 in this function, so we should have 0. So press your calculator correctly. This one we should have 125 over 6 units square. Done. Example 5. Example 6. Find the area bounded by the curve x equals to y square and the curve x equals to 8 minus y square. Right? So we have the curve here. So what we need to do here, we have to find the intersection point. So intersection point, how to get intersection point, we solve x1 equals to x2. Okay, so what we need to do, we take y square equals to 8 minus y square. Then we solve this one. So we have 2y square minus 8 equals to 0. So y square minus 4 equals to 0. So y minus 2, y plus 2 equals to 0. So y equals to 2 and y equals to negative 2. So we have y equals to 2 and y equals to negative 2, which means, so this one is negative 2 and this one is 2. Alright, to find the region here, so we need to use, so a equals to limits of integration is from negative 2 to 2, and we take the right curve minus lower curve. No, right curve minus left curve. So what is our right curve? Our right curve is this one. This one is our right curve. So which means we have to take 8 minus y square minus, what is our left curve? So our left curve is this one, which is y square. So y square, this one is dy. Okay, we simplify this one. So limits integration negative to 2. So we have 8 minus 2y square dy, and we integrate this one, we should have 8y minus 2 over 3 y cubed, and this one negative 2. Alright, so next is we substitute value. So we have 8 2 minus 2 over 3 2 cube, right, minus 8 sorry guys, 8 negative 2 minus 2 over 3 negative 2 power of 3. Right, so this one, you press your calculator carefully, right, and you should have 64 over 3 units squared. That is example 6. Right, example 7, find the area of the region in the first quadrant. So first quadrant that is bounded by y equals to set x and line y equals to x minus 2. So this time we are not given a graph, so what I would suggest you is to sketch the graph. Alright, so this one, sketch this graph, should have something like this. So this one is x, so this one is y, so y equals to set x, y equals to set x, something like this. And next one is y equals to x minus 2, something like this one. Okay, and the first quadrant only, so where is the region? So the region is this one. Alright, so this one is y equals to set x, and this one is y equals to x minus 2. Right, so what I do here is I will use y-axis to integrate this one. So first one, I need to find the intersection point. So where? So intersection point here. So I need to find the intersection point here. So intersection point, so I need to solve. x1 equals to x2. So in order to get this one, so this one I rewrite this one as x equals to y square, and this one as x equals to y plus 2. Okay, so let's solve this one. So y square equals to y plus 2. Right, so this one is y square minus y minus 2 equals to 0. So this one is y minus 2 y plus 1 equals to 0. So we have y equals to 2 and y equals to negative 1. Okay, so y is equals to negative 1 is somewhere here. So this one, y equals to negative 1 may be here, somewhere here. So this one is negative 1. So this one, we know this one is 2. Alright, to find the region here, so let's say we label this one as A. So A, the limits of integration, we cannot take negative 1 because negative 1 is somewhere here and this one is not in the first quadrant. So the lowest limit integration is 0. So 0 from 2. So right curve is this one, y equals to x minus 2, which is, in our case, we will take y plus 2 minus left curve, which is this one, and this one equals to y square dy. Right, so next we integrate this one. So we have y square over 2 plus 2y minus y cubed over 3, and limits integration is 0, 2. So next step is sub. So we have 2 square over 2 plus 2 minus 3 over 2. And this one again, if you notice this one, if I substitute 0 in this function, so we have y, this one becomes 0. Right, so you press calculator correctly, you should have 10 over 3. Again, don't forget unit square. Then example 10. No, done example 7.